try to bring the air out. Zero pressure. Now we are pushing the foam concentrate in the line.
Right.
And if we are...
Stopwatch? Here's how we do this. Here's how you stopwatch. Get a reading. We get a reading off the water motor, and then when Mark shuts that valve, start the stopwatch.
Now we are pumping against 12 bar. That is the pressure of the relief valve. No, that was water pressure, 2 bar, 30 psi, and here's 12 bar. It's 170 psi approximately. That's the opening pressure over here.
And our RPM went to 720 RPM. The reason for that is here we were pumping against system pressure, so there was very little back pressure there. And of course now it's got to do a little more work to overcome this pressure. So you get a little more pressure loss across the system with slows down. We have enough foam to go 2 minutes.
I would like to do the second time. If we are 1 minute, let's jump down.
Hey, when we got it.
Okay, you see our okay. Now we have done the measurement. The unit, according to the manual, is needing a quarter of a liter to do 1 rotation. So to transfer that into gallons, a liter is 3.6 gallons approximately, so we will need 0.07 gallons to do 1 rotation. We measured 720. That is 49.99 gallons a minute of flow. So it's 50 gallons. So
we ran it for a minute.
We wrote, and if we would see that we have 1% of 50 gallons, that is going to be half a gallon in the minute of foam concentrate. And if that mark is correctly, now, or we can balance it, what we are seeing here, we see that we are approximately at half a gallon per minute. So, but
yeah, it took an ounce off. Because we're at.
It's all gonna be off.
Now you've done it.
We did weigh the bucket before. The bucket was pound 5. When we did the startup for Valspar Kankakee, we had a digital scale and a drum sitting on a digital scale, and we just pumped into the drum and weighed what we pumped, and that was by far the easiest way to do it.
He's getting that off of this chart here, so you're looking at your, as in how many GPMs per revolution.
So
6 pounds, 13.3 ounces, and that, then it wasn't tared, so then we have to take off 1.53 ounces.
I'm not familiar with
Pounds and ounces.
now, and how to transfer that with a density into a volume.
And the density of this foam was 1.04 to 1.06, so we can use 1.05. or 1, almost close enough. So let's see here, ounces and pounds. 16 ounces in a pound, right?
How about that change over to the metric system, huh?
That's right.
Well done.
Yeah.
I would appreciate that.
They were,
Makes things easier.
when I was in
Great.
high school.
We were
or
about to
grade
change
school,
them.
Grade school.
They said, this is it, it's coming, you need to learn this, and absolutely, it's going to happen. They should have done it. They'd have been. It's such a better system.
Yeah, more exact now.
Oh, yeah, way easier, you know.
Yeah.
The only problem
way
I
easier.
have, converting and doing this stuff, no problem.
Yeah.
My problem is I don't know how far it is from here to there. I don't know how tall I am. I don't know how much I weigh in the metric system. I'm telling you, you're 2 meters tall. What does that mean?
You're too heavy. That's like you're too heavy.
5.77 gallons.
If you divide that by 50 gallons, so to be precise, remember the calculation, 5.5 gallons you said?
5.77. No, that can't
No,
be
that
gallons.
can't be right.
That had to be 0.5.
That's about
0.577.
0.577.
So if we have 0.577 divided by, and now we must think 100% is the base, not 99%. So we have to build the
55?
summary between the water flow
50.5.
and the foam flow to be correct. And then we have 50 gallons a minute flow, so we have to divide that by 50.577, and we will see, multiply that with 100, it's 1.14%.
1.14.
Because remember what I told you about the graph we are in the middle flow somewhere, so we are a little bit above the nominal pressure. We are at the peak of our admixture curve. And the ideal constellation would be if we have...
Well, like he was just asking on, the NFPA requirements is you have to be, you can be minus 0% and plus 30%.
30%.
And that's the range.
So we're within range fine.
From 1 to 1.3, that would be the range. And the ideal would be if we have a line connected to the foam store and we would have a ball valve here. So, and then we can adjust everything by cycling the foam concentrate. One takes the stopwatch, we're closing the ball valve here, that one goes open, and for a specific time we are pumping the foam concentrate in the measuring barrel or drum, and then after 60 seconds, for example, we open it again here, then we are cycling the foam concentrate, and we can balance or see what is the volume inside the measuring device.
In a larger system, I mean, keep in mind, you're flowing 50 gallons here. That 55-gallon drum works out nice if you got it graduated, or on the big ones we were doing, we're going into a tote even. I mean, because you're bypassing, even at Valspar, we're bypassing 55 gallons a minute. So on the larger ones, you're looking at your graduation and you're not down to the half ounce figuring out your percentage.
Yeah,
It's
3% system at 3% system at like 2,200 gallons a minute. That's what we were testing at. So you pump a lot of foam fast.
Can we redo that at 100 gallons?
if Justin can hold that hose.